So green software, it's really, has anybody thought about or working again towards green software at the moment? No? That's good. Well, it's bad, but it's good. It's good for this session. So this is really just kind of an introductory session to green software and why we should be thinking about it. Please shout any questions, any comments, any disagreements. It's kind of an interesting, it's a really new area, so we're all learning. So please, give me your thoughts. So why should we be thinking about it? Because if you move stuff from on-prem to the cloud, that's a good thing, isn't it? You kind of inherit all of those good things around sustainability that the cloud vendors are doing, whomever that vendor happens to be. But Brad Smith, our president, wrote a blog post, I think it was November last year, around sustainability and around how the demand for data centers is increasing. And essentially, he was saying it needs to be a shared responsibility, very similar to, when we talk about security and we talk about that shared responsibility model. Okay, we'll try and help, but then you've got to help as well with what you're writing and architecting. And so green software is very similar to that, is that the cloud vendors will help, but there's a level of responsibility for you. And I've just realized I didn't introduce myself, which I ought to have done. So I'll blame Nick for that one. So my name's Simon Furman, as per the previous slide. I work at Microsoft as a cloud solution architect. I'm in the app innovation team, so working with Azure, work alongside John. So when I say kind of cloud vendors and stuff, kind of talking from an Azure point of view, but broadly across all vendors, GCP, AWS, all vendors. But yeah, I work at Microsoft, working with customers to build stuff on Azure. So we're seeing the demand for compute increase. I mean, some of these numbers, I'm not going to go over, I'm sure you've seen a lot of these before, but a fifth, 20% of electricity in 2025, so in 2 years' time, will be going towards data centers. That's astonishing. That's the world in which we live, the world that we have some influence over. And there's the shared responsibility. It's kind of up to you to think about your software and your solutions, that are they working in a sustainable and efficient way? And that's really what this is about, is how you do that, how you think about that, because it's new. So this is a lower level, not hugely low level, but a lower level than move to the cloud and that'll fix it. And arguably that's correct. If you're working on-prem today, unless you're thinking about sustainability on-prem, the chances are if you move those workloads to the cloud, you will probably be more sustainable. You'll be emitting less carbon if you move them to the cloud. But this is beyond that. This is actually thinking about how we think about the architecture and actually how we think about the code as well, because code, some of the code structures actually influence how much energy is used in the machine. But we will get onto some of that. And then we've introduced the shared responsibility model. So some definitions, given you're all new to it, tell me if I'm in your way at any point. But some definitions, we talk about carbon all the time. We talk about carbon emissions all the time. But it isn't just carbon. It's actually, the way we see it written down is the CO2 EQ, carbon equivalence. It's just a naming standard. It's easier for us to say carbon emissions than it is to name all of the global gases that are actually being emitted. So it isn't just carbon, it's all emissions really. And we measure carbon in grams per kilowatt hour. So the way that we kind of annotate that is grams of CO2 equivalents per kilowatt hour. And that's how we think about it and measure it. We talk about clean energy, we talk about dirty energy, we talk about green energy and renewables. They're the definitions. Clean energy doesn't produce any emissions. Wind, wave, solar, those kind of energy sources. Green energy, the ones that come from nature and are renewable. Renewables, and they don't expire. We also, and we'll talk probably about this quite a bit, we use proxies all of the time when thinking about this area. And the reason why we use proxies is because it's really difficult to measure at the moment. If I say, what is your carbon emissions of your software, you've probably got very little idea. So we use proxies as a mechanism to think about it and influence it. And we'll talk more about that. And I actually think the proxies we use, most of the time it's cost, some of the time it's performance, most of the time it's cost. The notion there is that if we reduce cost, if we measure cost, if we reduce cost, we're likely to reduce emissions, which is a reasonable assertion given what we have from a tooling point of view today. That's likely to be the case. And I think cost is a really good analogy for where we are with green software in another way. If you think back to the early days of cloud computing, sort of 10, 11, 12 years ago, it would be quite common. I kind of joined the team speaking with customers about Azure then, and it was quite common for us to, have this cloud conversation. Move your stuff to the cloud. It'll be cheaper. And of course, the next question is, will it? Yeah, probably it'll be cheaper. How much cheaper will it be? Well, how much does it cost you at the moment? And of course, no one had a foggiest idea how much their software on premises cost them 10, 11 years ago. They might have had an idea how much it cost to develop, but they might, the machine they bought, the licenses they bought, power, cooling, hosting, the buildings, they had got no idea what the holistic cost was. But today, you go ask someone how much that particular piece of software costs. Not only can they probably tell you what that cost is, if they change it and make a release tonight, they can tell you what the cost is tomorrow morning, what the difference of that change was. So in 10 years, we've gone from not knowing, and as software developers and architects not really caring about the cost of our software, to really caring about the cost because we see the cost in the portals and in dashboards and in Power BIs. That's where we are with sustainability and green software today. We don't know what the numbers are, but we know we need to care. And in hopefully less than 10 years' time, we're working with a lot of the product groups at Microsoft to get these numbers out. But you'll get those numbers more quickly than 10 years, so you will see the difference. Make sense? Brilliant. Okay, so no demos, but websites. So the Green Software Foundation is the foundation that is perhaps pivotal to a lot of, blame it on the surface, a lot of what is happening in this space within our industry. So a lot of what I'm talking about is from the Green Software Foundation. I'm a member of the foundation. Microsoft's a member, a whole bunch of other companies. It's not aligned to Microsoft. Google has just joined last week. Google joined. Accenture are members. Avanade are members. There's a whole bunch. You can go look who's members. So a lot of what we're talking about will be from the Green Software Foundation. So one of the early things that the Green Software Foundation did was to come up with a set of principles. I came up with 8 principles of green software. And these are the ones that are on the bottom. Now, these are V1. They've now moved to V2. But I still like to talk about V1, but I've changed the word principles to definitions, because a lot of these ideas, these definitions, are still relevant in the new principles that we'll take a look at in a while. So the first few, and you get the gist of why they've changed them. They've sort of consolidated them and made them a little bit more, I guess, easy to understand. Carbon efficient, and remember, this is from a software, a developer, a solution architect, building stuff perspective. Be carbon efficient, and it's kind of an obvious thing to say when you're thinking about green software, but to a software developer that isn't thinking about being carbon efficient today, it's quite an important principle that actually be carbon efficient when you're thinking about your software. And we'll get on to kind of what that means in a little bit more detail later. The next one is very similar to the carbon efficient, and that's energy efficient. And again, as a software developer, how many developers think about the energy they are consuming, they are asking for when their software runs on a server? So we're saying be more energy efficient. And I appreciate you need to be able to measure these things if you want to change these things, but we'll get onto that in a while. But the concept is there: be more carbon efficient, be more energy efficient. So this is where they get a little bit more interesting. Has anybody heard the phrase carbon intensity? No. That's kind of good and bad in a way, but good for this. But you've got to walk away from here knowing what carbon intensity is. So carbon intensity is the amount of carbon, and remember it's carbon equivalents, the amount of carbon that is emitted at any given moment in time in any given location. So this is a visualization of this electricity maps. Sorry for the flickering. As we can see, within the UK, at this moment in time, we have got 209 grams of carbon being emitted per kilowatt hour. That's from the grid. These numbers, as you might imagine, are from the grid within the UK. You can see you go up to Sweden, 18 grams. It's always 18 grams in Sweden. The Nordics are very green. We can go look at other countries, 752 grams per kilowatt hour, and then France again is always pretty good. But the notion of carbon intensity is the amount of emissions at this given time at this given geography. And why does this change? It changes because of demand. And of course, if I read something many years ago that in the UK, and this probably just in the north, so I can say this here, when I'm down south in Reading, this doesn't land so well. But during the break of Coronation Street, everybody goes and puts the kettle on, and the demand for electricity goes up. It does go up. And so in order for the grid to meet that demand, it has to basically increase the amount of energy, the electricity. And the way in which it does this, and we won't get into this today, but it does that through dirty energy. It burns coal. And that's to do with how green energy is and how dirty energy behaves. You can't capture green energy, sustainable energy in the same way. You can't ask for more in quite the same way that you can from dirty energy supplies. So this is why carbon intensity is really important. That if the demand is high and you're putting extra demand on that, then you're essentially saying, go burn some coal, go burn some more gas to increase that energy supply in order that I can consume it. The flip is true as well, by the way, that if you're not asking for energy when the carbon intensity is low, because you can't capture that green energy, it gets lost. Which is an interesting, but that's another topic. But that's carbon intensity. Embodied carbon. This is an interesting one. Embodied carbon is the amount of carbon emitted in the entire life cycle of a piece of hardware. Whether that's a phone, whether it's a server, whatever it happens to be. It's basically saying the carbon emitted in the entire life cycle of this product is what's measured by embodied carbon. The notion there, of course, is, and this is interesting coming from a software vendor, don't force people to throw their stuff away. Make it last longer. I've had this phone for many years. Don't force me to go buy a new one.
We'll just interject.
Yes, absolutely.
Make the stuff repairable.
And make the stuff repairable.
Give you an error and then disable anything above, 30 FPS. So when you replace the screen, it'll disable your true tone, it'll limit, it'll turn off the ambient light sensor. So if you set the brightness screen,
Can I do that, please?
Yes.
I know where you're going.
Nonsense.
But it is, and
Make the stuff allow people to actually fix the things that they've got, and you'll get a lot more efficiency out of it.
Yeah. I think more of the hardware manufacturers and suppliers are cottoning on to this idea. How that impacts the business model is another interesting story. So
software too. Something that Android got a good phone.
Yeah.
They're not doing security updates, so you can't use it for work.
Exactly.
And so you buy another phone.
Yep.
Yeah. iPhone, the one that usually get like 5 years or 4.5 years software updates or whatever. This is an S10, and I'm pretty sure support dropped at the end of last year.
Yep.
It's not an old phone. I mean, this is running the factory firmware, so it's not exactly secure anyway, because I'm not really, I was going to say it's a more lax approach than most would, but yeah, it's completely down to the vendors of Android phones. Like, if they just sell the phone and say, yeah, we're not going to use any software updates, what are you going to do? You're going to have to replace the phone.
And this is why getting vendors on board with this, which is what's happening through GSF and through other organisations, is equally important, and it does impact the business model for sure. So they're going to have to think about that. We get on to climate commitments in a bit, which is where it all links together. So we kind of finish that story kind of in a bit. There's no easy solution, but we kind of close the loop on the story. Energy proportionality is linked to energy efficiency. Remember, energy efficiency is about being efficient with, do the most amount of work for any given unit of energy. Energy proportionality is just extending that slightly. So if you think about a server switched on even when it's not doing anything. It's a web server, it has to be switched on because it has to be waiting for requests. So it's talking about density. It's talking about making that bit of kit do as much as it can do for every unit of energy. So it's about increasing density on that piece of hardware, which is interesting. There was an interesting blog post out of AWS a few weeks ago. I don't know if you saw it, but it was basically saying how if you move from a microservices architecture to a monolith, you didn't see it. You can be a lot more sustained. Very, very interesting. Different lens on, as architects, as developers, it's a different lens on kind of how we're thinking about stuff. But that's all about energy proportionality. Networking, for those of you who've been around for a while, the web services days, service-oriented architecture days, a lot of this stuff is what you've heard before. Be efficient over the network. Think about the length of the network, the number of switches that you're going through and routers you're going through. Think about packet size, reduce it. Think about chattiness of network. Don't make it chatty. Send all the information that you can whilst thinking about packet size at the same time. All stuff that we've thought of, when we're thinking about web services and stuff. So demand shaping, you've probably already figured this one out. Demand shaping is linked to carbon intensity. So demand shaping is if you know the carbon intensity today, at this moment in time, in the geography that you want to run your software, you can make a decision on whether you want to run that software at this moment in time or not. So if we go look at, I won't flip it again because it'll send it all strange. But if you go look at the UK at the moment, and it's 175 grams of grams of carbon per kilowatt hour, do you need to run this software at this moment in time, or can you run it in a couple of hours, or can you move that software from the UK and go and run it in Sweden? That's what demand shaping is all about. Kind of an interesting concept. The ultimate there, of course, is making our software carbon aware, which is really where we're going. Makes sense? And then finally, optimization is you need to do or think about all of these things. You can't just do one of them. So they were V1. This is the current principles. And as you can probably see from the right-hand side, in fact, both the headings on the left and the 6 principles on the right-hand side, you can see where those previous 8 definitions fit into. So we've got carbon efficiency again, that's thinking about being carbon efficient and being carbon aware. Energy efficiency, about energy efficiency and energy proportionality. Carbon awareness is that demand shaping. We've got hardware embodiment. We've got that in hardware efficiency, and then they've introduced 2 more. measurement and climate commitments. So we'll go have a look at those. So I'm sure most of you are familiar with the Greenhouse Gas Protocol, GHG, Scope 1, Scope 2, Scope 3. Everybody familiar with that? Most companies have to report that now. They have to report what their Greenhouse Gas Protocol numbers are. So there's an emissions dashboard for Azure that will, if you're using Azure, you can download the emissions dashboard and give it your billing key. It'll pop up in a bit, and it will report on your Scope 1, Scope 2, Scope 3 emissions within Azure. And legally, lots of companies have to do this today. And guess what? You give it your billing key, so it's actually using cost as a proxy. So it's basically figuring out what your cost is in your Azure agreement, your subscriptions, and it's equating those to what your different scopes are. And just talk about what the scopes are. They get kind of a little bit weird in Scope 2, Scope 3. Scope 1's obvious, it's direct emissions. As your company, it's your direct emissions. So the obvious example of that is, you're putting diesel in your vehicles, they're Scope 1 emissions, because you control those as part of your business. Scope 2 emissions are indirect emissions. So examples of that would be purchasing energy to run your servers, your lights, whatever it happens to be. They're Scope 2 emissions. And Scope 3 emissions are everything else. So the example that we give all the time is the supply chain. So if you're producing products, anything in that supply chain for that product production are your Scope 3 emissions. And you're responsible for all of those scopes, and you have to report those. Is what, sorry? As your costs to you is a Scope 2, yes. Sorry, this is not real data, but it'll break it down into the regions that you've got subscriptions in. You can go install it, and it'll tell you what the algorithm is and how we figure it out in quite detail. So it'll tell you how we figure out what our Scope 1, Scope 2, Scope 3 are, and therefore how we report it to you. So Greenhouse Gas Protocol, Scope 1, 2, 3, is useful as a company. As different companies, we have to report on them, but they're quite large in terms of granularity. They're quite large numbers, and as software developers, architects, they're perhaps not that useful for us if we're changing a bit of software and we want to see what the impact of that software is. The Green Software Foundation came up with this formula, software carbon intensity calculation. And this calculation, it looks a bit weird, but all of the things to plug in now. It gives us the number of carbon emissions for our software. We take the energy consumed in kilowatt hours by our software. We multiply that by the carbon intensity that we go get from, for example, the electricity map. What I didn't show you is watt time is another well-known API. There are a bunch of APIs. We multiply those together, we take the sum, and then we add on the embodied carbon. So if it's running on a server, we need to know what the embodied carbon of that server is. If it's running on a mobile phone, we need to know what the embodied carbon of that mobile phone is. And then that number is per, and we say functional unit. So if we're building an API, it's per API call. So it gives us an intensity number for our software. So these numbers today are not readily available. So the energy, what's E for the server that you're running on? It kind of goes back to your question earlier on, what's E for that? We've got the carbon intensity. Admittedly, it's approximation because we're using the grid. Embodied carbon, well, that's, again, not readily available, or at least something that we all know about. But what's happening through GSF, the Green Software Foundation, is that a number of data sets and a number of APIs are becoming available from different vendors that will detail what their energy requirements are per server, per units of servers as well, and then what the embodied carbon is. So the idea of this, and remember, we're really early on in this journey now. You don't in a bunch of years' time, what I've said to the Visual Studio team is I want to push a button on Visual Studio, and I want it to tell me what my carbon emissions are at this particular moment in time. And then I want to make a change, and I want to push that button again, and I want to know what the impact of that change is on carbon emissions. That's where we'll get to, in the same way that, if you think about cost again, I know I've talked about that before, used it as an analogy. Look at Azure Advisor, for those of you familiar with Azure. Not only do you know what your cost is now, it goes advises you to tell you, go change things. Again, we're speaking with the Azure Advisor team to say, actually, we really need emissions in this as well. You need to be telling people to go change things because of the emissions. Make sense? No.
Just go back to your lovely button in Visual Studio that
Yes.
I think is amazing.
Yes.
Wouldn't that be within a dev environment?
Yes.
And how does that, would that be reflective of what's going on in the bigger world?
No. But yes. So I'm kind of having this conversation with GSF at the moment. So into this, I've introduced a discussion that says actually we need to think about runtime versus host time. So, or design time, whichever you think about it. So a lot of what we're seeing at the moment is a host time, is a runtime kind of capability. It isn't a design time capability. So what I really want to know as a developer is what influence I have over design time, what changes I make, but equally when I go run it, ultimately that's what's important. I need to know what, but you're right, it needs to.
So effectively, could there be a scenario where you create a unit test that measures sort of power, if you could create a set of tests that you can run in a dev and a live, and then compare the diff, and then that'll give you technically what you're looking for?
It will.
But how about things like, we're working more of a connected environment these days, things like Blazor, and you are doing a lot of signal R calls and stuff like that. That gets all a bit messy, doesn't it? It's not just a simple request.
It's not a simple request, and Microsoft does a global hack every year where the whole company can choose to get involved in this hack. I got involved as just a small team. There's 3 of us that played around with this, and there are utilities. So HP have one that measures the energy consumed at any given application. So you can start this utility up and you can run your app and it will tell you what the E is. Because of course what you've just said means that you need E plus, in fact, you only really need E. To think about design time changes, you only need E. Because I is dependent upon time and location. M is dependent upon the device, because it's embodied carbon at that server over there or that mobile phone over there. So if you're thinking about design time changes, you only really need to measure E. So as long as you can measure the energy consumed, make a change, then measure the energy consumed, you know whether you're getting better or not. Because as design time, that's what you're doing. Runtime has got different, a lot of what we've been talking about is runtime stuff.
We've noticed is that a lot of people notice that ARM is a lot more efficient than x86. That's why it's on every mobile phone. Are we thinking about, because I've got been involved with it, thinking about targeting the environment to suit it better? So if you can cross-compile to ARM and you've got a lot more power efficiency, that could be a thing.
The simple answer is yes, but again, it goes back to where are we on the journey, and we're so early on this journey at the moment that those conversations, that I'm not aware of those conversations. They're not part of the Green Software Foundation that I'm aware of. Suppliers are, and hardware manufacturers are thinking about these. We're thinking about it as a software company in terms of the hardware we get, and we think about it in terms of Xbox gaming and the impact that has. Windows, seeing the changes for Windows. Depends. It depends. I mean, that's why it's interesting, isn't it? Because it does depend, because you talked about Blazor and are we doing more in the browser, microservices, that blog post about microservices versus monolith. Just it depends. I think it's that balance of understanding with the design time and the runtime and getting that balance together. You can.
What are your views on what is Microsoft doing towards, or anybody, or just general views on
sort of the IoT thing, and everything's going to be sending signals to every device that we potentially have.
Yeah.
The energy consumption around that. What is the energy foundation, going to do around that?
It's
technically you have mass everywhere, right?
Yes.
Whatever, you're going to have all these devices, then isn't that to be a massive power hungry thing that would regenerate?
the simple answer is yes, but then it comes to the business reason for doing it and stuff like energy proportionality, which is if you need to do it. And so let me try and answer this in a different way. When we'll get onto carbon, we'll get onto climate commitments as well, which answers it in a different way. In fact, let me go into climate commitments, then we'll have this discussion at the end, because I'm going to preempt something in a bit if I answer that question now. So I'm sure measurement was one of the new principles, which we just talked about, SCI in particular, software carbon intensity calculation. This is the other one, climate commitments. Basically saying, companies have to start to think about what their climate commitments are, what their strategies are. And it's really important to understand those strategies, because if you are helping your company move towards its strategy, you need to know what that strategy is. And hopefully that will become clear. You'll have heard of these terms. We tend to use them interchangeably quite a lot, but actually they have very precise definitions, and a lot of them are owned, if not all of them, are owned by standards bodies now. So if we look at the left-hand side, and this is part of an answer to your question. If you want to reduce the emissions that you are emitting, there are two ways of doing that. You can either offset or you can eliminate them. It's called abatement. You can eliminate them. Here's what I was going to say earlier on. During the pandemic, there were a whole bunch of surveys done, but one particular survey that I read, those 2 years that we all were locked up at home and weren't traveling, weren't going on a holiday, blah, 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 what percentage of global emissions were reduced? I remember some of those pictures on the news of those big cities that they could see there, that smog layer had gone. And anybody, I would not have got the number right, by the way, but anybody guess what the number is? 50.
I mean, there's no cars, there's no trains, there's no.
Yeah.
Maybe
70? 12? There's no prize, I don't think, unless Nick's got one. So the number, and there are lots of different studies out there, but so therefore it's kind of just an indication. It's 7%. 7. And
isn't probably as big as a lot of people thought.
Nowhere near. No. The point being of that is to eliminate, to abate carbon emissions in today's society is really, really difficult, if not impossible. Which is why having an understanding of climate commitments and what you want to do about it is really important, and figuring out what that approach is. So offsets abatement are the high level approaches of doing this. So if we break down the offsets, there are two approaches to offset. One is to compensate. They say avoid, but I don't really like the word avoid. I prefer compensate. And the other one is neutralization. So just to give an example of this is an aeroplane flight. If I want to go on an aeroplane for holiday, for example, and I want to offset that, I will pay John not to go on holiday. So I'm offsetting my carbon emissions. I'm going to take the flight, I'm going to do it, but I'm offsetting, which is why I like compensation as a better way of avoiding. The other one is neutralization, is I will neutralize those emissions that I've produced. I'll still take the flight, or I can not take the flight, but that's really more elimination, it's abatement. But if I'm going to take the flight, I've got to come up with a strategy of removing those emissions. So carbon capture is a mechanism of doing that. So on the right-hand side, which links to what we've just talked about, these terms, when we talk about being carbon neutral or net zero, they have precise definitions. So if you make an assertion you're going to be carbon neutral, what you're saying is you need to measure your carbon emissions, and for 100% of those emissions, you need to offset them. You can offset via compensation or neutralization, it doesn't matter. But if you take 100% and you offset them through one of those mechanisms, you can be classed as carbon neutral. Net zero is a very different approach. Net zero, you measure your emissions, and for 90% of those emissions, you have to eliminate them. You have to not emit in the first place, which, given what we've just talked about on the pandemic, is really, really, really difficult to do. And the remaining 10%, you can offset, but you have to neutralize. I can't pay John, I have to not go on the holiday, or I have to capture. And that net zero is where we need to be on the target, which we're looking like we're going to fail in the next few years. But by 2025, the agreement of 1.5 degree increase, it's actually 2% is the target, but we really want to get to 1.5 degree increase. Net zero, sorry, is the path to that target, which is why it's there. So at the moment, we're doing carbon neutral, but we're targeting net zero, but we're carbon neutral. So, and we want to be carbon negative, which basically is offsetting more than you use. So if you use this much, if you offset a little bit more, you're carbon negative. We've said that, I forget the date now, but we're going to be carbon negative by 2030.
Some notion of offsetting is all the stuff we previously.
Yes, which is the carbon negative bit. Yeah, and we're doing that through capture mechanisms and carbon capture mechanisms. I've got no idea where I am on time, Nick. That's right. I'll be really quick. All right. Okay.
No, it's all right.
Last slide anyway, I think. One more slide after this, and I'll be quick. So the other things I just wanted to make you aware of, Green Software Foundation have worked on and released something called the Carbon SDK. So we talked about demand shaping and carbon intensity earlier on. Rather than you having to write code that says go look at the carbon intensity of this, where I am at this given time using the API on what time, or the National Grid have one as well. The Carbon SDK abstracts that for you. So it's a software developer kit you can go install. You sign up to what time or whatever API you want to get carbon intensity from. You plug that key in, and then you can use it in your software. And the other thing is there are lots of patterns on the patterns.greensoftware.com, I think it is, to give you architectural patterns to think about working towards with sustainability in mind and reducing those emissions. Final slide. There are some interesting advantages of this. The bottom bit is the bit I like, because of where we are today in the world. Actually, the goal of sustainability ought to be enough for companies to justify this work. I'm working with a bunch of companies at the moment that it is actually being sustainable, and making these changes is enough. But actually, and we've used cost as a proxy quite a lot, that if you do think about being carbon efficient, there's highly likely that you're going to reduce cost. So there are some interesting business benefits as well as the sustainability one. From a coding practice point of view, it's making you think in the same way that a bunch of years ago for cost, it's making you think about how you write lines of code, and not always, using maybe the current on-trend standards of microservices and stuff, but it's some interesting discussions there. Better forecasting, so it enables you to predict what the costs of in the same way, again, it's cost as a proxy. You don't have to go offset as much. You don't have to go buy carbon tokens and offset. So again, from a business point of view, and it extends, if we think about embodied carbon, it extends the life cycle of servers and of mobile devices and laptops and all of those things. And that's me done. Apologies for running over. Sorry.